first of all, let's have a look at the equation. Anything wrong? No. Yeah, that has to be factored. That's something between, if there's nothing between the negative and the x, we have to put a parenthesis in there, which means we have to factor, and we have to factor because there's another parenthesis. So this is going to become f of negative x plus 3. When I look at this, everything's happening inside, right? So nothing's happening outside, which means nothing vertical is happening, which means nothing is happening to the y's. So I can do that right away. But two things are happening to the x's. They're getting flipped, which means we do what in mapping notation? Put a negative. And they're getting moved 3 to the left. Minus 3, not plus 3, minus 3, because it's going to the left. Get your reference points from the original graph. So this one is negative 3, 1. This one is negative 1, negative 3. This one is 2, 2. And I may even want to add another one along this stretch here, just to be safe. So I'm going to add 6, 2. You don't have to, but I just want to make sure I'm precise at the end of my transform graph. Okay, so we've got negative 3 that we plug into here. What does this work out to? 0, because it becomes 3 minus 3, which is 0. Y doesn't change. Negative 1, when I plug it in here, becomes positive 1. Minus 3 is negative 2. Y doesn't change. 2 plugged in here becomes negative 2 minus 3, which is negative 5. 2 doesn't change. 6, when plugged into here, becomes negative 9. Well, that's going to go off the graph. That's okay. We can just ballpark it. And then the y coordinate 2 doesn't change. Notice how when I do these things, when I take my reference points from the original, I always start to the furthest left and work my way right. Because that way, on my new graph, I'm going to be starting to the left and working to the right and connect as I go. So 0, 1, negative 2, negative 3, connect like so. Negative 5, negative 2, sorry, negative 5, positive 2, connect. And then negative 9 is out here. So it's going to go like that. And if you think about it, if you look at it visually, it does make sense because the negative inside tells us that we're taking the red graph, flipping it horizontally, so it's going to look like this, and we're moving it, 3 to the 3 to the left. Yes, so I was looking at the original. Okay. All right. This last one that we're going to do with graphing, notice it involves something else. Absolute value. When you take the absolute value of a number, what do? Like, what's the absolute value of 5? What's the absolute value of negative 7? Right, so if it's positive, the absolute value stays the same. It's negative, the absolute value changes sign. Okay? Whenever you see absolute value, it always affects the y's. Always. So when we do mapping notation, we're going to take the absolute value of the y's. So if we look at this, first of all, let's get our reference points. I'm actually going to add one here. So I'm going to go negative 3, 3, negative 1, 0, 1, negative 3, and 2, 0. Okay. Because if you think about it, with absolute value, the absolute value bars are on the outside of the function, aren't they? So if they're on the outside of the function, they're affecting the y's. Only anything that's in here affects the x's. So are the x's being affected at all? No. There's nothing going on inside. So that means x's are not going to change at all. But the y's will. What are we going to do to the y's? We're going to make them negative, and we're going to multiply them by 2. This is also on the outside, which means what else are we going to do to it? Because that's absolute value. Oh, sorry. What am I doing? My mistake. Yeah. What we're going to do is we're going to take the absolute value of y, because that's what we always do, absolute value first when you see it. Then we're going to multiply it by 2. And then we're going to shift all the y's up 1. So we add 1 to the y's. Okay. But don't do the absolute value of 2y. Take the absolute value first, then multiply by 2. So with the new points, we said the x's aren't changing. Okay. 3. Absolute value of 3 times 2 plus 1. Absolute value of 0 times 2 plus 1. Absolute value of negative 3 times 2 plus 1. Absolute value of 2. Oh, sorry, absolute value of 0 times 2 plus 1. There we go. Connect as you go. Remember, this one has the arrowhead on it. So this one becomes negative 3, 7. This one becomes negative 3, 7, and it has the arrow. Negative 1, 1. Connect. 1, 7. Connect. And 2, 1. Connect. if you look at it visually, so you may see like, okay, that's kind of weird. I don't know if that's right or not. Well, think about it. If, like, let's take this point. If we take the absolute value, it stays where it is, right? Yeah. If we stretch it by 2, that means we double the y, so it comes up here. And then we add 1. So it's right. This one, we take the absolute value, it stays where it is. We double it, it stays where it is. And then we add 1. This one, we take the absolute value, which means it flips up to 3. Then we double it, then we add 1. So you can also do it graphically. You could even do it graphically to check if it makes sense to you. Okay? Any questions? All right. I'm only going to do one of the next ones. Like a lot of times, you won't have to go through this whole complicated process that we're about to go through. Okay? Like, for example, and you've seen some of these already. You don't have to write this down. Or you don't have to copy this down. Like, let's say if I gave you this was the original, red was the original. Blue was the new. Okay. And I asked you to write the equation to get this from this. What's the, like, what transformation is happening? Stretch by 2, still need one word, vertically. Vertical stretch by 2, that means it affects A. A is 2. So the only thing you have to do in the transformation equation is put 2 in for A, and you don't even write B, H, or K. So this would be F of X. That's it. So a lot of times you can get them from that. Just looking at the graph and doing it mentally. Like if I gave you this one. This is getting a little bit more complicated. From red to blue. Horizontal flip. Horizontal flip takes it over here and it's still a V. Vertical flip takes it up here. So vertical flip, yes. And then it shifts 1 to the right. So that means that if it's a vertical flip, A is negative. And if it shifts 1 to the right, H is 1. So it would be negative F of X minus 1. Okay. But what happens if there's multiple things going on? So these ones are going to be a little bit more complex. Because here's the original. Here's the new one. You can probably see some things that are going on. What do you think? Vertical flip? Horizontal flip. Yeah, it's horizontally flipping for sure. Yeah, it looks like it's stretching. Which way? Like this or like this?
Like this.
Like this?
Oh, vertical.
Looks like it's stretching vertically, like it looks like it's stretching in.
Oh.
Okay, so right away, you guys have picked up a couple of things. So, all right, what we could do then, pick a point. That's not on the X or Y axis. Why do we not choose the X or Y axis? Because when we stretch them or flip them, nothing happens. So I want to pick a point out here. Or you could pick this point, you could pick this point, pick that point. I usually like to pick a point on the end. Okay. All right, you guys told me that it flipped horizontally. So it went over the y-axis, right? So that means this one goes out here. You also told me that it stretched vertically. Now, how much did it stretch? How can we find that? If you think about it, find the total height of the figure from the lowest possible point on the figure to the highest. What is that height? 6. What is the height of the new one? 3. Remember, we're talking stretches, so we're talking multiply. What do I multiply to get from 6 to 3? Half. Right? So that means this point, which we already horizontally flipped, stretches by a half, doesn't it? So don't I take half of 4 and go down to 2? So it's out here. With me so far? Okay. So we've already talked about, we said, okay, flip horizontally, you should keep track of this, B is negative. And it's stretched by a half. A is 1/2. So right now, if we flip this and stretch it by a half, we're here. We're at the point 4, 2. Where should we be? Sorry, -4, 2. We should be at -3. It should be here. So it shifted how? Because remember, we don't, all the stretches are done, all the flips are done. The only thing left now are the shifts. It shifted one to the right, horizontally, right? Which affects what letter? And it's 1. So what we did is we picked a point on the original. We see if it's stretched and flipped. And once we did the stretches and flips, we see if there was any shifting left. Okay. So I've got all this information now. B is negative, A is 1/2, H is 1. So that means G of X, and if you don't write the G of X equals, that's fine. Okay. A, which we've said is a half. Then F, open bracket, because we've got B and H, so we need brackets and parentheses. B is negative. Open parentheses, X minus H is 1. Close the parentheses and brackets, there's no vertical shift going on. Yes?
So my question is, what if instead of the brackets we did parentheses?
Double set of parentheses? I'm fine with that. I'm okay. That's common too. Yeah, if you want to do that, that's fine. How do we do that? Okay? Okay. Because I just taught that a completely different way than every other year. I just saved you a ton of work.
Thank you.
So, and I think it'll work. Because before I used to write what the stretches and flips were, and then I did the transformation, and then I figured out what the shifts were after, and sometimes it got confusing for students. But I think if we try it this way, you'll be in better shape. But oftentimes, from what I've seen on the provincial, these kind of questions that you'll see aren't that complex as these. It's more the second one that I gave you, the one that flipped and shifted. Those are usually the ones that they like to put on there. Okay. Okay, so I'm going to stop with that one.